Alright, so moving on to chapter 4, we're talking about trigonometric functions. Trigonometry is essentially the study of triangles. It's basically just geometry, but only involving triangles. So first thing we need to talk about are some just basic things with angles and things like that. So right here, we've got an angle. We call, if we said the angle open in this direction, then we would call this side the initial side, and then the side that the angle stops at, the terminal side. Okay, and of course here is a vertex. Okay, so that's the basics of an angle. Now, knowing those about angles, whenever we put, in trigonometry, a lot of times we'll put angles on the coordinate plane. So whenever we do that, for the angle to be in standard position, the initial side is always on the positive x-axis, right there. All right, and then the terminal side will be anywhere depending on how big of an angle it is, right? If it's 90 degrees, then right there would be your terminal side. If it's 180 degrees, right here. 270 degrees, it'll be down here. And also, if the angle opens this direction, counterclockwise, it's a positive degree angle. But if you see it open going downward in a clockwise direction, then that is a negative degree angle. So if it opens down here, that would be a negative 90 degree angle. But if you see an arc pointing that it's open in this direction, like this, then that is positive 90 degrees. Okay? If it came down like that, that would be negative 90 degrees. So the direction dictates whether it's a positive or negative angle. All right, so next thing we talk about is a radian. What is a radian? Okay, a radian, if you haven't heard of a radian yet, is another way to measure an angle besides degree. So just like we can measure distance in feet, or we can measure it in meters, right? There are two different ways that we have of measuring a distance. Well, there's actually a lot of different ways to measure distance, but those are two examples. There are two ways that we use to measure angles. One's degree that you're pretty familiar with. A radian is a new concept. Yeah, so here's what 1 radian is, okay? 1 radian of a circle, and this is the same for any circle. 1 radian is always going to be whatever the angle that you have to open up at, that's theta. Okay, theta is a Greek letter we use to represent angles a lot of times. So whatever angle you got to open it up at to where this arc, the crust of the pizza, is the same distance as the radius of the circle. Okay, so think radius, radian. So however far you have to open up your angle to where the arc that angle makes is the same length as the radius, the distance from the center to the outside of the circle. That measure is 1 radian. And we know that in a full circle, okay, which is 360 degrees, okay, if we're converting measurements, we know that that is 2 pi radians. Alright, so a full circle is going to be 2 pi radians. So then 180 degrees, which is half of a circle, is just pi radians. Alright, so I'll show you a little visual right here of that. So, okay, so this line right here, if we open this, starting with our initial side, if we open to our terminal side, if we went all the way to here, that's 180 degrees, right? Because it makes a straight line. That is pi radians. Okay, so I'm going to put pi right there. Of course, if we went all the way around 360, like I said a minute ago, that is 2 pi radians. Okay, so then knowing that, if this is pi, then what would 90 degrees be? Well, that's halfway to pi, so 90 degrees is half pi, or pi over 2. Okay, it's half of a pi, because half a circle is pi, so that's 1/4 of a circle, that's half a pi. So then, of course, if I went to here and then down 90 more degrees, that's going to be 1.5 pi's, right? So that's 3 pi over 2. 1.5 is 3 halves. Okay, so you add on a half every 90 degrees. Every 90 degrees is half a pi. All right. and every 180 is 1 pi, every 360 is 2 pi's, right? So we can say 90 degrees is pi over 2 radians. Okay, and these are ones that are important to know because they come up so much. And of course, 270 degrees is 3 pi over 2 radians. Alright, so hopefully you understand the concept of a radian. Again, it's however much I have to open this angle up, however far that terminal side has to go in order to make the radius the same distance as the arc over there. Okay, and you can fit 2 pi of them, which is, remember 2 pi is about 6.28. You can fit 6 of those in a full circle. 6.28 of those radians would fit in a full circle. So you can imagine if I took this this angle and copied another one, it might end somewhere around in here. And if I did a third one, it would end somewhere around in here because you have 3.14 of them in half a circle. So there's going to be 3, and that little space left is about the 0.14. Okay, and then you have a 4th one, then a 5th one, then a 6th one somewhere right here, and then you've got the 0.28 left over to get your full circle because there's 2 pi of those sections in a circle. All right, so hopefully we have a good idea of radian measure. It's important to understand something with your quadrants. We have the first quadrant right here, your second quadrant, your third quadrant, and your fourth quadrant. So it's important to understand that if an angle measure is between 0 and pi over 2, it's going to be in this first quadrant. Okay, so theta is greater than 0 and less than pi over 2 up here, right? Because once you get to pi over 2, that's 90 degrees. You're about to go to the other quadrant. Okay, up here, theta is from half a pi to pi. Down in your third quadrant, theta is going to be from pi to 3 pi over 2. And then your fourth quadrant, theta is from 3 pi over 2 to pi. So not pi, 2 pi. So any angles in those ranges are going to have a terminal side that ends in those quadrants. Okay. For example, if I said an angle was pi over 6, well, pi over 6, a sixth is less than a half and more than 0. So that would be up here in the first quadrant somewhere. But if I said that it was 3/4, 3 pi over 4, well, that's 3/4. That's more than a half less than 1, so that's going to be in the second quadrant. All right. Okay, so now let's look at how to sketch and find coterminal angles. So coterminal angles is kind of what it sounds like. They're angles that are terminal at the same spot, right? So they have the same initial side, of course, and the same terminal side. So it says find a coterminal angle for, and it might be kind of hard to see that, that's theta equals 13 pi over 6. Okay, so for angles to be coterminal, you've got to do another full circle in either direction to stop at the same terminal side. Okay, so a full circle in radians is 2 pi. So that means to find another angle that's coterminal 13 pi over 6, I need to either add 2 pi or subtract 2 pi from 13 pi over 6 in order to get one that's coterminal. Okay, so let's just subtract 2 pi because 13 over 6, that's more than 2, right? 13 over 6 would be more than 2 because we know 6 times 2 is 12. So let's subtract 2 pi from that. 13 pi over 6 minus 2 pi. And you can type it on the calculator. Don't type in the pi's, just type in the fractions, 13 over 6 minus 2, and just know that you need to have a pi with it. So I could just convert this to sixths. So 2 is really 12 sixths. 13 6 minus 12 6 equals 1/6, or 1 pi over 6. So that's an angle that would be coterminal with 13 pi over 6. And we can draw both of those angles. All right, so 13 pi over 6 is 2 pi's, right? So I would go full circle, and then another sixth of a pi, which would be about right there. Because think pi is here, right? So if I divide this upper section into 6 sections, right? Because I'm talking about a sixth of a pi, then I need to think about where would a sixth be. Well, here's a half, so I would need 3 sections on each quadrant, right? So I'd have 1, 2, 3, 4, 5, 6. So that would be about a sixth of pi, somewhere around in there. About a third of that first quadrant would be a sixth. All right. So we draw that angle 13 pi over 6 by going a full circle and then ending our arrow on that terminal side. Okay, so that would be 13 pi over 6. Now, if we want to draw pi over 6, we know they're going to stop at the same sides and start at the same side, but pi over 6 is just going to be 1/6 of pi. We're not going to go a full circle to draw the angle. So the blue one is 13 pi over 6, and pi over 6 is the red angle. All right, so let's do another one. This time it's 3 pi over 4. Okay, 3 pi over 4, that's less than 2 pi. It's not a full circle, obviously. So let's add 2 pi this time. You can do either. You can add 2 pi or subtract 2 pi to get a coterminal angle. So 3/4 pi plus, you make 2 into 4, that's 8/4. So 3 plus 8 is 11 pi over 4. All right, so let's draw those. All right, so first let's do 3/4. Well, this is pi, right? To here is pi, so we want to go 3/4 of the way there. Here's half of it, and then another fourth would be halfway from there, right? So we got a fourth, 2/4, 3/4, 4/4. So 3/4 is halfway through that second half. All right, so that would be our angle for 3 pi over 4. All right, and then we added another 2 pi to get 11 pi over 4. So 11 pi over 4 is going to do a full circle and then come back around and stop there. Okay, because you added a full 2 pi, which means you added that full circle in. Okay, let's do one more. 2 pi over 3. Well, I'll say it's negative 2 pi over 3. All right, so since it's negative, we can add 2 pi to that to make it positive. So we add 2 pi, let's make that into thirds. Negative 2 pi over 3 plus 6 pi over 3 would be 2 pi, right? So make it 6/3. Negative 2 plus 6 is 4. So 4 pi over 3 would be our coterminal angle to negative 2 pi over 3. So let's draw those real quick. All right, so negative 2 pi over 3. That means we go down, right? Negative angles are going to be drawn going clockwise. So if I go 2/3 of the way to pi, right? Pi would be to here. Half of a circle is pi. So I go 2/3 of the way, a third's probably around in here, 2/3 is probably somewhere in there. We're just rough guessing right here. So that would be our negative 2/3. Okay, but when we add a full circle to that, let me make sure I have my initial side in there. And I did put an initial side on this one. All right, so whenever I do 4/3 pi, I've got to go up, right? It's positive, so I've got to go 4/3 of the way. So that's going to be 1 pi and then another third. Okay, so the blue angle is negative 2/3 and the red one is positive 4/3. Both of those will end at that side. Okay, because one I go 2/3 of the way down, the other one I go a full pi and another third to get me to the same line. So I'm going to pause the video real quick. You guys try these next few. Your coterminal angle is 8 pi over 3, and for B it's 5 pi over 4. And right there you can see the drawings. The blue angles are the angle you were given, and the red ones are a coterminal angle you found. Now you could have found different ones if I added 2 pi on both of them. If you subtracted 2 pi, you could have found a different coterminal angle that could be correct. Okay, so there's multiple right answers on those sometimes. All right, so now we talked about how there's 2 different angle measures. There are 2 different ways to measure angles, radians and degrees, and we got to be able to convert from one to the other, just like you need to be able to convert inches to feet and feet to miles and all that stuff. So there's a little, like the key that we use to convert is either pi over 180 or 180 over pi, depending on which one of you're converting to, if you're converting to degrees or radians. So it just depends which one of those you use. You're going to multiply by one of those to convert from one to the other. So these are pretty basic. All you need to remember is whatever you're multiplying by, or whatever you're whatever you're starting with. If you're starting with degrees or radians, whatever you're given, you're going to put that on the bottom. Okay, so this is 180 degrees. So I'm given for A, I'm given 135 degrees. So I'm going to pick the one of these that has degrees on the bottom. All right, what you're changing to needs to be up top. So I'm going to multiply 135 by pi over 180 because I have degrees, so I need to use the one that has degrees on bottom. So that's going to give me 135 pi over 180. All right, now I just need to reduce that fraction. Okay, don't type the pi in the calculator, just type 135 over 180 and hit math, enter, enter, and it'll reduce the fraction for you, and it gives you 3 pi over 4. So now we've got 135 degrees as a radian measure, 3 pi over 4 radians. Okay, so 2. 2 does not have a degree on it, right? So it's a radian measure. It doesn't have a pi, it doesn't have to have a pi. You should have 2 radians, okay? So I'm going to take a radian measure, since there's no degree symbol, and I'm going to multiply it by the one that has radians on bottom, 180 over pi. Okay, so 2 over 1 times 180 over pi is 360 over pi, which is going to give us a decimal. You can just leave it as 360 over pi, okay? But you got to make sure that you put a degree symbol on it, right? Because we're changing from radians to degrees. So you got to put the degree symbol on your number. The degree symbol is key. So it's 114.6 degrees roughly if we round it. All right, the next one is a radian because there's no degree symbol. So again, we're going to multiply by 180 over pi. So on this one we get 180 pi. And on the bottom we've got 2 pi. Of course it's negative. So then the pi's will cancel out, and I've got 180 divided by 2, which is just 90. So it's negative 90 degrees. Okay, then this one's degrees. So I'm going to use pi over 180. I got to put degrees on bottom. So 270 pi over 180. Sorry, it was negative 270. Now you reduce the fraction. Don't type pi in, just type negative 270 divided by 180. Math, enter, enter. And it gives you negative 3 halves. And then you just remember to leave the pi up top. So that degree, negative 270, is really negative 3 pi over 2 radians. You guys try the next few and I'll go over. So for A part, 9 pi over 2 is 810 degrees. For B part, 540 degrees is 3 pi radians. And for C part, 3 pi over 4 is 135 degrees. All right, so let's move on. So finding arc length. Okay, a circle has a radius of 4 inches. We want to find the length of the arc intersected by a central angle of 240 degrees. So it wouldn't hurt to have a picture of this circle. So maybe we can get us a circle up here to kind of visualize this a little bit better. Alright, so it says it has a radius of 4 inches. We want to find the length of the arc intersected by a central angle of 240 degrees. So if that's my initial side, 240 degrees is going to be down here somewhere. So it'd be an angle like that. I want to figure out what's the length of this arc. Right? If this angle is 240 degrees that we open up our angle, or our angle at. Okay, so there's a formula to do arc length. It's a pretty basic formula. The arc length is just the radius times the angle in radians. So that the theta right there we use has to be in radians. So S is arc length. Of course, radius is R, and then theta is your angle, but it's got to be your angle in radians. Okay, so we plug in the radius 4 times the angle. Now the angle is 240 degrees, but we need to convert that to radians. So over here to the side we'll do 240 and multiply, make that radians and multiply by pi over 180. So 240 pi over 180. That's going to reduce down and give us 4 pi over 3. So what we're plugging for theta is really 4 pi over 3. So our arc length is going to be 4 times 4 pi over 3. So we type that in, and you get 16.76 roughly inches. All right, so that distance all the way around is 16.76 inches. All right, so that's how you find arc length. go ahead and try the next one on your own. Remember, you've got to convert a degree measure to radians to plug into your arc length formula. All right, so as you can see right here, we converted 180 degrees into pi radians and then plugged it into our formula, did the radius, which was 14 inches, times the angle, which was pi radians. 14 times pi gave us 43.98 inches, which would be the arc length of a circle with a 14-inch radius and with a 180 degree central angle. All right, so now let's look at finding linear and angular speed. The formulas for each of these are pretty simple. Linear speed is, when you think of speed, that's what we're talking about. We're talking about linear speed. Linear speed, is just distance over time. So for the example of a circle, it's going to be the arc length over time. So think about how much of your tire, the distance that your tire moves along the ground. And then angular speed, it's kind of what it sounds like. It's the central angle over time. Of course, that central angle is in radians. Okay, so let's use this problem right here to figure out what our linear speed and angular speed are. So it says the car tire makes 9.3 revolutions. Well, a revolution is a full circle. We know a full circle is 2 pi radians, so we can convert 9.3 revolutions to radians very easily by multiplying by 2 pi, because we know each revolution is 2 pi radians. So we multiply that, and we're not going to multiply by pi, we're just going to make it 18.6 pi, multiply 2 times 9.3. So our radian measure is 18.6. So you can find the angular speed at this point just by taking the angle that we know. So if it's 9.3 revolutions, that's 18.6 pi radians, and putting it over the amount of time it took. So it says it does 9.3 revolutions per second, so our time is over 1 second. So that's just 18.6 pi radians per second. And that's what they said. They wanted it in radians per second. All right, now to find the linear speed of the car in inches per second, we need to figure out what is the arc length. So we got to use our arc length formula. We know it's 18.6 pi is the angle measure. We multiply that by the radius. Well, it says it's a 15-inch diameter. So 15-inch diameter is all the way across. The radius is half of that. So 7.5 is half of 15. So we need to multiply those two together. And of course, we put it over the time, which was 1 second. So 18.6 pi times 7.5 gives us 13,545 pi per 1 second. All right, which is going to give you how many inches times that by pi? 42,552.87, and that's inches per second. All right, so go ahead and pause it and try this one for yourself. All right, so the trickier part on this problem is that initially it gave you your revolutions per minute of the saw blade. But the question wants you to put your answers in feet per second and also in radians per second, right? And of course, this is in inches. So what you got to be able to do is convert 2,400 revolutions per minute into how many per second. So 2,400 divided by 60 will give us 400 revolutions every second. So I want you to know the number of revolutions, times that by 2 pi, because each revolution is 2 pi radians. So we know we got 800 pi radians per second. All right, so that's the rate of the angular speed, is 800 radians per second. And to find the linear speed, you've got to figure that out. And wants it in feet per second, right? So we need to change this to feet. I initially did inches, just realized it needs to be feet. So we need to figure out how many feet is the radius. Well, if the diameter is 7.5 inches, then the radius is half of that, which is 3.75 inches. How many feet is that? We'll divide that by 12, and you get 0.3125 feet. All right, so 3.75 inches is 0.3125 feet. So we multiply that by 800 pi, and that gives us 785.40 basically feet per second. All right, so that's your linear speed, and then you get your angular speed, 800 pi radians per second. Now let me know if you have any questions on this. If you don't, you can go ahead and start practicing with these problems. Thanks.